sir, init ID after booting kernel or
No, see, basically init ID is the image you are recording. No?
yeah,
Init ID is the image which is created. See, what happens is that init ID requirement only comes for the generic kernels. Most of the time, otherwise people will not use. Generic kernel, what happens when distributions build a kernel, they are not stick on to the motherboards, right? Like this motherboard has a gigabit motherboard, this may have some Intel desktop board, some may have AMD MA. See, in x86, what is going to happen is that different motherboards are there. Now, what is going to happen in different motherboard has a different configuration. They may have different north bridge controller, different south bridge controller, different APIC IC, different Ethernet controller, different, all are different, right? Now, what is going to happen is that storage controller, for example, one may have the storage controller from Adaptec, another may have storage controller LSI Logic. These different companies have different storage. On the motherboard, you can have any IC, right? Or maybe Intel storage controller only on Intel motherboards. Like this is there, then what is going to happen is that they cannot have the dedicated kernel built. Then what they will do? They will do a minimal kernel build and other all things they will build as a module. Now what is going to happen is that when you install the OS, when you are using Debian or Ubuntu or Red Hat or Fedora, when you install, at the installation time it will go through the board configuration and it will find out which is the south bridge, north bridge and the storage controller, and it will automatically, those drivers it will put it in RAM file system and Ethernet controller, and it will put it in the RAM file system. And RAM file system is a small file system which will, after the you can see the grub in boot grub now. If you see the entry, first entry will be for the kernel, then grub will load the init ID. Now grub first kernel will load and it will take the init ID and it will run the file system, and when it is running it will load all the drivers inside the, then only it can detect the real storage. See, once it loads the chip driver only, it can access the hard disk now, because hard disk controller is there. Hard disk controller driver is not there, how it can access hard disk, right? That is SATA controller, it should first detect. That's why those drivers will be loaded, then SATA controller will be detected. Then why RAM is there? RAM is anyway detected by the processor, right? That's why it will, because we can't access till now hard disk. You got it, no? That is why it will first load and it will access the these drivers will be loaded. Once these driver will automatically allow the storage to be loaded. Once storage is loaded, it will mount the file system from that particular partition of the hard disk. Then it will boot. You got it, no? That's why it is required. Secondary partition is our main partition. Data is kept in the partition, no? Wherever we install it, the root file system will be kept in the hard disk, right? That will be mounted and it will be booted like that. Clear? Okay, now any other things we have discussed last time? Proc and sysfs we discussed, right? Last time we discussed about proc and sysfs. Proc is and sysfs is a RAM file system. RAM file system means it's a virtual file system created by Linux, which is totally a virtual. See, it's created in RAM, where it is a file system used for interaction between the processor, interaction between the user space and the kernel space. Why it is required? You want to do something, let's say you want to debug or you want to get some information about the kernel. Proc is very important. I showed you that day cat proc bus input devices. It will show you the devices, input devices plugged in. That is a very, very important kind of information which you will get it. Which devices are plugged in, which devices are unplugged. All those information you will get it in the proc and sysfs. Now coming back to the, that time I showed you proc IO mem, where all memory mapped addresses were there for different chips. Before you come actually I showed them. Proc IO mem. There is something command called proc IO ports, which will show all your IO mapped IOs, IO mapped IO devices, right? And there is something called cat proc interrupts. You can see that. Which all the interrupts are occurring, it will show you. Just to see the cat proc interrupts on this. You can see legacy devices will always get the legacy IRQs, like IRQ4, 3 for this one. Most of the time IRQ3 for the serial controller. Just check now interrupts.
RTC timer is 0, one is 8048, parallel port is 7. And RTC 0 is 8, Ethernet is 42, sound HD, SND HD.
Right, you got the idea, right? Now, see, this is a very important, proc interrupt is very important. Sometime when you are debugging your drivers now, you are implemented some interrupt routine, and whether your interrupt is coming to the routine, like hardware interrupt, sometimes interrupt may miss now. That's a miscount is there. You can see errors, miscount, everything will be there in the interrupts. You have to keep on observing that. You can use a command called watch. Have you seen a command called watch in Linux?
I've heard, but I'm not using it.
Say watch a space, you can give the command. Then it will, for given second, periodically, watch will keep on dumping on the screen.
Watch LS you can.
Watch?
LS.
See, watch is, you can use some command in the, for example, if you do watch ls, regularly
Any
it will
changes,
keep
it will.
on. It will keep on showing it. Watch is very critical. Say interrupts you want to watch, with how it is going on.
Watch
Right.
only for command or even for the files?
Huh?
Okay, unless it should be.
Yes, should be command output keep on changing.
Okay.
Right?
When you
For file you can use tail.
Okay.
Tail. There's a command called tail minus f file name. And keep on dumping. If file is changing, you keep on, it will dump on the screen. Right? You can use watch command to make sure that whether, see, this is very critical for us actually. Keep on observing. Right? Because interrupt miscount or anything, you can get it and you can say any issues are happened, you can capture it. Right? This is very important. Now coming back to the other things I already showed, cat proc, IO ports and IO mem. Other they have already seen actually. So those commands also there. There is another command called you can even get about PCI devices information called LSPCI. LSPCI. This is a command, and LSPCI if you run minus VVVV, you can get complete PCI configuration space.
LS PCI.
Minus VVVV.
See. Controller,
In that completely you are getting the PCI configuration 64 total how many bytes are coming, just see.
We're getting list of all the PCI
Devices, yes, and with all the data actually, your configuration, vendor ID, device ID, you can see this. First bytes. There is a PCI configuration information also. You can go to the internet. I will explain you that. This, see, the same way you can do a LS USB for the USB devices. LS USB together you type. LS USB together. LS PCI also together.
unable to initialize LS USB.
I think it requires some migration.
What happened? LS USB?
Unable to initialize like USB.
Okay, you can try here. I will show you here. See this LS USB. Connected all USB devices will be showing. You can see now. In my case, there is one Bluetooth chip is there,
HP pad.
and then one keyboard is there, Dell computer. one Microsoft optical mouse is there connected. Then one video cam is there, webcam is connected also. These are the devices which is connected in my. These two are internal in the laptop. Okay. Then LS USB you can do VV. To give the complete details, endpoint, descriptors, everything, information class, everything it will give. This is once you study the deep of USB, I'll explain. Till that these are not that much required. There is another command also called ls hal. ls hal, you can see this. It will give you the complete description about your devices on the board. ls HAL. Right. And another command proc CPU info. Can you type that proc CPU info?
CPU, only CPU. New pattern, CPU. Use more space.
Can you check the CPU parameters? What are the things are there?
LS CPU.
Cat proc space proc slash CPU info.
This is a vendor ID, CPU family, model name, CPU megahertz, 1200, microphone address, cache size.
What is the cache size?
Cache size 2 KB, 2048 KB,
2 MB.
2 MB. Yeah.
The virtualization capabilities also it will show.
Each processor can be individually addressed. They are showing two processors, 0 and 1, dual core. They can be addressable, each of them.
Each processor can be addressable. It's a dual core, no?
Yes.
2 processors will come in. You've gone through the CPU info?
Yes.
Yeah, that's core 0 and core 1 is there, no? Same way, mem info is there. Cat proc mem info. It will give the information about the RAM. Just can you go through that proc mem info?
swap total, swap free, write back, anonymous playlist, map, shared memory, snap. This is only for RAM, sir. Slash memory.
Yeah, it's for only for the RAM.
Address RAM.
So why total RAM will not show complete size of the RAM? So some difference will come. Yes.
Which on total RAM?
Sir.
Some of the things may be dedicated to video RAM. That's
We
why.
have to count that video RAM and then we will get total RAM.
Total RAM,
How
yeah.
you calculate it now, sir?
No, divided by 1024 and divided by 1024. It's actually in system information we applied in next one. So that time I got difficult. I told 2GB around 2GB.
Yes, yes.
We have to add a video RAM size also.
Video RAM.
I'm calculating it now.
CAD proc, MTRR is there. That is very, very important actually in x86. There is something called MTRR. This will give you how much it went for some other people. Slash proc MTRR. MTRR means memory type range register.
What are the details?
Basically, MTRR is like you want to use some of the RAM for other people, like video or maybe some other kind of guard, HB guard or maybe hard disk. You want to allocate in the RAM through an earth bridge controller or maybe say there is processor provides a there is a setup empty memory type range registers where we have to set up that entry. What type of caching, write combining or write through or this kind of caching, where it will be useful for us to use as a caching for the video. See, this is a write combining caching for the video RAM. How much it is given? CAD proc MTR.
Already done,
Huh?
that's all.
2048 MB size.
Register 00012344. Each one, first one is 0 MB, next is 2 GB. 2 GB, 2 GB, 2 GB.
There is
Uncache, write back is 0 MB, uncacheable is 2 GB, it is 2013 MB. Uncacheable,
write combining nothing is there, na?
write combining is
0 MB size equals 20486.
256, huh?
size 8.2 plus MB.
That's all gone to video.
Okay.
How much it went?
2 plus MB.
256 MB went to that video.
Oh, that's the base.
Huh?
Base. This is starting address. That's a starting address, I think. Write command.
6 MB for video RAM.
Uncaching and write back.
That's for video caching. Clear? Following commands and in sys bus platform devices. You have seen the day all the devices which are there in the. Can you go to the sys bus platform? The boot time, whatever the devices are there, it will come there. And go through sys class also.
Device pro, drivers pro, drivers auto, even,
Drivers problem that formation delay.
See, in the sys bus platform devices, there is something called platform. All the devices which are there, no, it will appear. If you go to system, that is the CPU, where you can CPU scaling based on the DVFS, no, dynamic voltage frequency scaling is no, recent power management thing, or
Platform devices.
Platform sys bus platform devices. There is a folder called system.
System we are not able to find. In platform we have only two
Devices
drivers.
and drivers.
Okay, you go to sys devices,
Yes, and
sys
six bus.
devices platform.
Sys devices.
Go to system.
Devices. Platform. System. System.
You see there
CPU.
CPU. Yeah. Here all CPU related parameters and which are the main core running now online core. Every information you will get it about the CPU. Means if two cores are there, which is online now, which is offline, and which is running,
CPU 0, CPU 1.
all the information about CPUs will be coming. In the system only there is a information about RAM also.